Hello everyone, and welcome back. In this tutorial, we're going to do something really interesting inside STAR-CCM+. Instead of building a geometry from scratch, we're going to reshape an existing CAD surface using the Freeform surface tool. Our example is the lower element of a race car rear wing. And the goal here is simple. We want to deform that wing surface in a controlled way using control points, displacement vectors, and design parameters. This is a very useful workflow when you want to explore shape changes quickly without rebuilding the whole model again and again. So let's jump in. We start by loading the provided simulation file. In the tutorial, the starting case is dual-element wing_start.sim. Once it opens, save it as freeform.sim so we can work on our own version. Now go into Geometry, then 3D CAD Models, and open the dual-element wing model for editing. At this point, we want to deform the lower wing element. But before the Freeform surface tool can be used, there is one important limitation to keep in mind. It only works on a single surface or patch. That means we first need to prepare the geometry properly. The wing in this example is already cut in half because of symmetry. So the lower element still has a face lying on the symmetry plane, and that face needs to be removed. So first, set the saved view shown in the tutorial so the lower wing element is clearly visible. Then select the face of the lower element that lies on the symmetry plane, right-click, and choose Delete Faces. Confirm the selection. That step converts the lower element into a sheet body, and now it becomes ready for freeform editing. This transition is where the symmetry side face is deleted and the lower wing surface becomes the active patch for morphing. Now right-click the lower surface of the wing element and choose Freeform Surface. As soon as the tool opens, STAR-CCM Plus displays a UV grid over the selected surface. This grid is basically the framework that we'll use to control the deformation. And right now, it's a bit too coarse, so the next step is to refine it. Go to the Display options in the Freeform Surface panel and open the settings for the number of grid rows and columns. Set the grid rows to 10 and the grid columns to 6, then click OK. Now the UV grid becomes denser, giving us more positions where we can place control points and shape the surface more precisely. Next, we need to define the correct boundary condition on the symmetry side. Select the boundary glyph on the edge that lies on the symmetry plane. Then in the boundary constraints, set the boundary constraint to planar and the planar condition to normal. This is a very important step because it helps preserve the symmetry behavior while we deform the surface. STAR-CCM Plus keeps that edge normal to the plane, which gives a much cleaner result when working on half-model geometries. Now we can start shaping the wing. Choose Create Point, move the cursor over the boundary edge on the symmetry side, and place a control point at the location shown in the tutorial. Then click that control point to select it. A triad appears in the scene, and this triad gives us directional control over the deformation. We can drag it visually, or we can type in exact values for more precision. For this first change, the goal is to move the wing profile downward. So in the displacement of point settings, set the Z value to -0.0826 meters, then click Apply. Immediately, the lower wing surface deforms downward. This is the first major shape change, and it gives the lower element a much more aggressive form. Now here comes the parametric part. Instead of leaving that displacement as a fixed number, the tutorial turns it into a design parameter. So go back to the 3D CAD tree, create a new length parameter, rename it to wing height, and set its value to -0.0826 meters. Then return to the Freeform Surface Edit panel. Select the same control point and replace the Z displacement with $wing height. Press Enter, click Apply, and now that deformation is fully tied to a parameter. That means later, instead of manually editing the point again, you can simply change one parameter value and update the shape. Next, we're going to shape the underside even more by adding a U-curve and 2 additional control points. Rotate the model so you're looking up at the underside of the lower wing element. Then choose Create U-curve and place the new line between the existing grid lines at the location shown in the tutorial. After that, place 2 control points on this new U-curve. The tutorial places them roughly near the centers of the 2 curve segments, and it also mentions that you can hold Control while clicking if you want to place multiple points one after another. Now set the displacements for those 2 points. The tutorial gives these values in millimeters. For the first point, the one closest to the symmetry plane, use 8.955, 0.000, minus 102.397 millimeters for the second point. The one closer to the end plate, use 8.633, 0.000, minus 16.932 millimeters, then click Apply. This expands the lower wing surface and creates a much more pronounced change in the underside profile. To refine the shape one more time, the tutorial adds another control point directly on the lower surface. Create that point at the location shown in the document. Then set its displacement to 0.009, 0.000, minus 0.061 meters, and click Apply. This extra point helps flatten the shape locally and smooth out the overall result. And once again, the tutorial does not stop at a manual edit. This final control point displacement is also exposed as a parameter. Select that control point, go to Displacement of Points, click Expose Parameter, and name it Wing Depth. Now that movement is stored as a design parameter as well, which makes the whole deformation process even more flexible for future updates or design studies. At this point, the freeform shaping itself is done. So click OK to complete the freeform operation. But remember, earlier we converted the lower element into a sheet body. So now we need to close it again and turn it back into a solid. To do that, double-click the large free edge highlighted in green so STAR-CCM Plus selects all connected free edges. Then right-click and choose Fill Surface. As you can see, the window gives an error indicating that the loop is not closed. So, probably one edge has not been selected properly. So, let's zoom in and find it. Click OK. That fills the missing surface and converts the lower wing element back into a solid body. And with that, the geometry update is complete. We started from an existing dual-element rear wing, prepared the lower element for freeform editing, refined the UV grid, fixed the symmetry side boundary condition, added control points and a U-curve, and then used both direct values and design parameters to reshape the surface. Finally, we filled the open edge and converted the geometry back into a solid body. So this is a great example of how STAR-CCM Plus lets you do fast and powerful CAD morphing directly inside the software, without rebuilding the geometry from scratch. And that can be incredibly useful when you want to explore different design variations quickly and efficiently. Thanks for watching, and I'll see you in the next video.